Okay, so we're going to be solving another question from the dynamics by Meriam, and we need to determine the tension P in the cable, which will give the 100-pound block a steady acceleration of 5 foot per second squared up the incline. So what we have in here, we have the acceleration in this direction, which is 5 per second square. And yeah, as always, we're going to start with the free body diagram of the block. So we have one single cable that goes around the pulley, which is attached to the block. So the tension in every single point of this cable is that force P that we have. And what we're going to do, we're going to do a cut in here and draw the free body diagram for the block, and we're going to show all the forces that we have. So if we cut that cable in there, we're going to have another force P in here. There is this force P in red that question is already showing. We have the normal force perpendicular here. Because the box is moving up the incline, the friction has to be in the opposite direction, so we can call this our friction force. And obviously we have the weight of the block, which is 100 pounds. So we can call our x and y in this question. We can maybe call this one x, and this will be our y. And we have our equation, sum of all forces in x equals to mass times acceleration, and we're gonna have a similar story for the y direction. So let's start with the x. So we have the force P that is positive. We have the x component of the other force P, which is P cosine of 30 degrees. We have the friction in the opposite direction. We know friction is the coefficient times normal force. Obviously the system is moving, so the friction is going to be kinetic, and we need the kinetic coefficient, which if we look at the question, we have it as 0.25, and okay, so that's going to be negative 0.25, and we're going to have the x and y component of the 100 pounds. So this is going to be the x component. Because that angle is 30 degrees, this angle right here would be also 30 degrees, and the sine of that angle would be our x component, negative 100 sine of 30 degrees. And yeah, that's all the forces that we have, and this will be equal to mass times acceleration of gravity. Keep in mind that we have the weight of the box or the block, so we have to divide that by g. Because our unit are in foot, our g would be, I'm just gonna show it in here, 32.2 foot per second square. So we're gonna divide that by g to get the mass, and times the acceleration from the question. We know it's 5. All right, so let's clean up the equation a little bit better. So we can factor P from the first one, 1 plus cosine of 30 degrees, negative 0.25, and that would be equal to 100 times 5 divided by 32.2 plus 100 sine of 30. We know it's 0.5, so it's going to be 50. So that's our first equation from x. Let's move on to sum of all forces in y, mass times acceleration. Obviously here there is no movement in y direction, so this will be equal to 0. And we can have the normal force upward, so positive. We have the y component of the p, which is going to be p sine of 30 degrees, and the y component of the weight, which is 100 cosine of 30, and it's going to be negative. And yeah, that's going to be everything for y. So another equation that we have is 0.5p plus n is equal to 100 cosine of 30 degrees. So that's going to be our second equation. And what we can do in here is that we know from this equation n is equal to 100 cosine of 30 degrees minus 0.5p. And if we just plug this in the first equation right here instead of n, we're going to have one equation based on p, and we're going to get the p 43.8 pounds. And the final answer for this question, because we need to find the p, so there's no need to plug it in to find the n from the second equation, but that's going to work too. Everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.